Okay, this is Mr. Ward, and this is the pre-algebra 20 week do now 25.2 week 25 weekday number 2 video key. So we are going to need this information in class. We need to find out. So first of all, a hydrogen atom really is just a proton when it doesn't have its electron, and really the mass of a proton is pretty close to the mass of a hydrogen atom. As you can see, 1.67 times 10 to the negative 27th kilograms is pretty much what we use for the mass of a hydrogen atom on our last set of do nows and so forth. All right, so how much would the mass of 5 times 10 to the third protons be? All right, so to deal with that, we need to set up an equation. So we're going to say 1.67 times 10 to the negative 27th times 5 times 10 to the third. Then we need to group things. So we're going to group the coefficients, 1.67 times 5, and the powers. So it's all powers of 10, so I can just, and they're being multiplied, so I can add the powers, 10 to the negative 27 plus 3. Okay, so what is 1.67 times 5? Well, it's 8.35, and then our power is 10 to the negative 27 plus 3, which is 10 to the negative 24th. And that's in kilograms. All right, so that's something we'll store away as information we need today. Because I'm going to be demonstrating to you that gravity is weak, well, compared to some other things. Now, what would the mass of 4 times 10 to the 4th protons be, using all that same basic idea? So I'm going to put the equation here. So there's your mass of 1 proton, 1.67 times 10 to the negative 27th, times 4 times 10 to the 4th protons. And then I group my coefficients, 1.67 times 4, and then my power is 10 to the negative 27th plus 4, and we figure out what 1.67 times 4 is. It's 6.68. And then 10 to the negative 27 plus 4 is going to be 10 to the negative 23rd kilograms. So it's not a lot of kilograms. And we need to simplify this expression. Now the bases are all C's. So inside here, we would use the product law. So we'd add. Between here and here, we would subtract minus 4. But this is the power law, so we're going to multiply this times each one of these things. So I'm going to first do it in a few steps, and then I'll show you a one-stop shopping approach. So first, I would start organizing this numerator. This numerator is going to be, well, actually, first let me restate that. First, I'm going to distribute this negative 2 times each one of those powers. So I took the c to the 5th times negative 2, and the c to the negative 3rd times negative 2. And then that's divided by c to the negative 4th, divided by, that should be a negative 2. I'll fix that in a minute. And then, that's weird. That should not be an 88. Okay, so that's okay. So I'm going to just deal with that. So negative 4 times negative 2 will be 8. And then c to the negative 10, that's 5 times negative 2, and c to the positive 6, because negative 3 times negative 2 is going to be 6. And now I can add the exponents in the numerator. So that's going to be c to the, I'm going to put it in parentheses, negative 10 plus 6 minus 8. And that's going to end up being c to the, well, 10, negative 10 plus 6 is negative 4. Minus 8 is going to be negative 12. Cool. Well, I said I'd have a one-stop shopping approach. Let's see this one-stop shopping approach. Since it's all C, I've got this stuff happening in the middle, but then everything is going to be getting multiplied times negative 2. So what I'm going to do is I'm going to say c to the negative 2 times all this business that's happening in here. So that's going to be 5 plus negative 3 minus negative 4. So 5 plus negative 3 minus negative 4. And then I'll simplify what's in there and distribute the negative 2. So c to the negative 2 times, all right, 5 plus negative 3 is 2, minus negative 4, so is going to be 6. So that's going to be c to the negative 2 times 6, which will be c to the negative 12, which is what we got before. You can approach this in many different ways as long as your ways are consistent with the properties of exponents.